Okay, sorry, Mike. Just a quick joke. As you see the number on the title of slide, it seems that Mike doesn't want to be retired for next 15 years. Okay, thank you.
The title of this presentation was the last part of it that I wrote. It was initially going to be called something like Things We Got Wrong in XSLT 3, but I thought that was a bit negative. So I decided to phrase it in a positive way. These are the things we can do next. So why should we attempt to do another version of XSLT? Why should we attempt to add anything? Well, first of all, there is a substantial user community of whom a tiny proportion of whom are here. If you try and look at numbers, it's very hard to get numbers. But if you look at the numbers of people asking questions on StackOverflow, XSLT is one of the top 25 languages in the world. That might just be because we're better at answering questions and therefore people ask more. So you can never quite tell. Or it might be because it's a very difficult language and therefore people have to ask a lot of questions. Who knows? But it's certainly up there with, it's a long tail, of course. It's not up there with Java and JavaScript, but it's up there with things like Erlang and F# and what have you. Users are doing increasingly ambitious things. We see some of those at these conferences, certainly. And certainly JSON processing adds an enormous amount. A lot of the ideas in this presentation came from some of the things that we've been doing ourselves. I talked last year about writing an XSLT compiler in XSLT. Earlier we've tried to write an XSLT schema validator in XSLT. Those are use cases which really stretch the capabilities of the language and show you what works and what doesn't work so well. I'm a software engineer, and being a software engineer means that engineering to me is unashamedly about putting resources into where they're going to deliver value. And so you can't separate effective engineering from effective use of resources to deliver things that are valuable to people. And so business and money does come into the equation. I make no apology for that. Unfinished business from XSLT 3. Now, a lot of the things in XSLT 3 actually seem to be pretty polished. Streaming, I think, works well. We found very few glitches in the final spec. There are a few things that could be added, but it seems to meet people's requirements. Packaging, there's probably been very little feedback on packaging because it's only people writing something big and new from scratch who actually can take advantage of it. So I don't think we've got the feedback there to say what works well and what doesn't. But the area where I think we do have a lot of feedback is using maps and arrays for complex data processing and particular JSON processing. And that's probably where I'm concentrating in this talk. And then there's a few things that are just low-hanging fruit, things that we could have done years ago, but didn't get round to because it was too easy and people were too busy doing more difficult things. There's always a lot of that in any language. So unfinished business, I think exploiting maps and arrays is what I want to focus on. The basics are there. The data model is there. The basic operations are there. But I spoke a couple of years ago here about using XSLT for JSON transformation and trying to do some use cases on it, and found that, in particular, the template rule model didn't work at all well for JSON structures, and that's because the patterns aren't there. Arbel mentioned the predicate patterns, which are the sort of basics for doing it, but when you actually try and use them to match parts of a JSON structure, it doesn't work well, and we'll see some more examples of that. Higher order functions as well, I think that's going to be the other sort of focus this afternoon. Enormous capability in higher order functions, which I don't think are fully exploited, and there are a number of reasons for that. And a lot of this has to do with the fact that XSLT in its origins has an enormous amount of capability for manipulating XML and rather less capability for manipulating anything else. And we need to sort of restore some of that balance. Let's remind ourselves a bit about the type system, which is at the fundamentals of this all. A reminder doesn't mean you're supposed to know this. A reminder means this is the status quo in XSLT 3 and XDM 3.1, I guess, more literally. The blue type hierarchy here, starting at schema types, that's about what's in the XSD specification. So schema types, you can have simple types, you can have complex types. Simple types divide into atomics and lists and unions. And that's what you'd write in a schema and use for validation. Schema types appear in the XSLT and XPath world primarily as type annotations on nodes. They also appear in cast expressions. You can cast to a union type. Union types have a sort of they start to appear in XSLT 3, but as somewhat second-class citizens. So provided you've defined a union type in your schema, for example, if you've defined union of date and date time, then you can have a function that accepts a parameter of that union type, which means it will accept either a date or a date time. And you can have a function that returns that union type, so it can return either a date or a date time. That's a powerful capability. Really adds flexibility. The problem is you've got to actually update your schema and add that union type to your schema and give it a name. So it's not quite as fully exploitable as one would like. Now the red type is much more the XDM type system. Item types are the types of values that you manipulate in XPath and in XSLT. So, well, sequence types are a sequence of items. Item types are the types of the items in a sequence. And the types of item you can have can either be atomic types, node types, or function types. And the functions can be maps or arrays. So there's the blue type hierarchy is the XSD world. The red type hierarchy is the XDM, XPath, XSLT world. And then you've got this funny thing of patterns, which aren't really types. They're predicates applied to things, and they have a sort of relationship to types, but not a completely direct relationship. And one of the respects in which XSLT is much better at handling XML nodes than other things is that patterns have a very strong relationship to node types and a very weak relationship to other kinds of types. And one of the things you need to do to make it better at processing maps and arrays is to make patterns map better onto maps and arrays. So that's where we are. It's very, very messy, and it's actually far worse than that if you really look at the gory detail. That's a gross abstraction and simplification of what's really there. So let's look at map types and JSON. This is an example of JSON taken straight from the XSLT3 spec. I noticed that when I copied and pasted it, it inherited its coloring, which is there thanks to Phil Fearon's brilliant colorer, which I hadn't even noticed springing into action. Let's try and assign types to the things in that JSON structure. What do you get if you do a parse JSON and get back maps and arrays? What are the types of those maps and arrays? Well, down here, these things, these objects called to and distance, it's a map from strings to items. Well, it could be a map from strings to any atomic type, to be a little bit more precise. What you can't say is, this is a map that has a to field that's a string and it has a distance field that's a number. The type system just doesn't have that level of precision in it. Here, this is an interesting one because we sometimes forget that in JSON, the keys in a map aren't always metadata. People use keys for data as well as for metadata. Names of cities, you probably wouldn't use as element names in XML, but people are perfectly happy to use as keys in a map in JSON. So our notions of data and metadata that we use in the XML world don't quite map onto what you find in the JSON world. So this one is probably a true map where both the key and the value are data rather than metadata. And we describe it as a map from strings to arrays of maps, and the maps are from strings to items. There's nothing there that's very sort of semantic. It doesn't tell us this is a list of cities. It tells us it's a list of maps from strings to numbers. And that means if you read a style sheet that says this function expects a map with this structure, it's not very self-documenting. It doesn't tell you this function takes distances between cities as its argument and returns the shortest route between cities as its result. And this map here, the top-level map, is again just a map from strings to items. It's the same type as this one. There's nothing there to say, if I want to match this map versus if I want to match that map, they're the same type. How can I distinguish them by type? I have to find some other way to distinguish them in match patterns. So what I'm proposing is a different way of describing maps called tuple types. And if we look at those as tuple types, and if you're familiar with JSON schema, then you'll actually see that tuple types here are very similar to the way that objects or maps are described in JSON schema. Perhaps start with the bottom one, where I've given the full description of the tuple. It's got a field called to, which is a string. It's got a field called distance, which is an integer. In this one, I've left a wildcard in. The wildcard comma star means that I don't mind what else there is, so long as it's got these things as a minimum. And again, I've left the types out, saying I don't care what the types are. Because when we're matching things in patterns, certainly, if you're doing validation, then you want to put the constraints in. If you're just doing pattern matching, you just want to provide enough information to distinguish it from other things. You don't have to provide all the gory detail. So if we have these sort of descriptions of patterns, then we actually get something that we can use not just as types in functions, but as something that we can use as patterns in template rules. And we can start to think about doing recursive descent processing using applied templates on this kind of structure in the same way as we do with node trees. So that's the idea with tuples. So you can use them in an as clause, tuple type there. There's an example of a tuple type. It's not a new type of value. We're not saying we've now got maps and arrays and tuples. Tuples are maps. It's just a different way of describing and constraining the type of a map and saying what you expect this map to contain, which gives you rather more information about its semantic usage than the raw sort of map from string to number does. So some technical details. A tuple type, it's a map when it's got statically known key names. You can have wildcards there, so you don't have to know all the names. You can make the tuple extensible. I've said that at the end, so the comma star says it can have other things as well. The keys have to be strings. I think in the first version of my proposal, the names had to be NC names, but discovered that doesn't work very well with JSON, because in JSON, objects can have any string as the key value. And so we ought to be able to handle any JSON, and so you can have any string there, and you put it in quotes if it's not a simple name. The field type default to item plus, not to item star. And that's because we're treating an entry whose value is the empty sequence exactly the same way as an entry that's absent. So if there isn't a middle name, you can interchangeably have it present and be an empty sequence, or have it absent. And that's because of the way maps work. You get the same answer from map get for the two cases. So entries can be optional simply by saying that it's allowed to take an empty sequence as its value, and that says it doesn't actually need to be there at all. And most of that aligns pretty closely with the way JSON schema allows you to constrain the values of maps. The difference is more in the way you describe the values, because JSON schema allows things like regular expressions to constrain the value. We do that through the type system of what kind of atomic types you have in there. So as well as using tuple types to constrain variables and parameters, you can also use them as patterns like this. And similarly, you can also use arrays types as patterns. In a sense, you could already do that using the dot square brackets, dot instance of. But one difference is that by making it explicit like this, you can actually have intelligent priorities attached to them. So you can start to get the same as we get with nodes, with actually a fairly intuitive allocation of priorities. And this turns out, I've done a couple of use cases, and it does seem to solve this problem of how to do recursive descent processing with JSON structures. There's another problem which I don't mention in this paper, which I've talked about at previous talks, which is that when you're processing JSON structures, you don't get any parent pointers. You can't look upwards towards what the ancestors are, what the context was. You can't say, I'm only interested in this kind of tuple if it's a descendant of such and such, because there's no upwards navigation in these structures. You have to find other ways of passing the context through, but there are ways you can do that. Now, one thing you find if I go back there, the things highlighted in red, there's a lot of repetition. And if you do a big application using maps heavily, you find that you're using the same types again and again and again. In the schema validator I wrote, we probably had 200 template rules all returning the same type of value. And so we had this same definition of the same tuple type appearing everywhere. And when you want to change it, if you want to add something to it or change the type of something, then you have to make the same change in 200 places. So very quickly you find that you need a way of naming these types, which I've called here type aliases. A little bit of debate about whether they should just be pure aliases or whether they should have some, whether they should actually be able to describe recursive types. This idea is due to John Snelson. I don't think John's here, but he's the person who gave me this idea in the first place, so I'll attribute it to him. Item types, they can have the same sort of system of import precedences and what have you as all the other named objects we define in the style sheet. And you can refer to them anywhere, basically anywhere that you can use a type. So you can say cast as type thing, you can say as equals type thing, you can use it in a pattern, you can use it in anywhere that you would be able to use the expanded form of the type. It doesn't give you encapsulation. It doesn't really, it looks like encapsulation in some ways, but the structure is still visible and exposed. What it gives you is more sort of modularity, that you've defined the type in one place and you only have to change it in one place if you need to make changes. So it's more of a macro capability than real information hiding. But it does sort of mean that you can expose a function library and the types that it returns, the types that it receives, and your users get a semantic, you document it as saying this takes a complex number and it returns a complex number, rather than this returns a map from strings to doubles. So it's a richer level of semantic description of the type, but not true encapsulation. Union types as well. It's not completely unrelated here, because you find that when you're dealing with JSON, you find you wanting to use union types more. What I'm doing with union types is simply saying you don't have to define them in a schema anymore. You can define them inline where they're used, or you can define them in a type definition in your style sheet. It's no longer tied to being schema aware. Unions can be used independently. In the same way as you use atomic types independently of having any schema awareness, you can now use union types independently of any schema awareness as well. So that's most of what I wanted to say about types and patterns. And the other main thing I wanted to talk about today, there's no clock in this room, is there? Use my old-fashioned wristwatch. I can't see that. Higher order functions. One of the most important new features in the 3.0 family of specifications, and grossly underused. I think there are three reasons it's underused. One is that it's an optional feature in the specs, and that means that one of the leading implementations decided to make it a feature that you have to pay for, which I think was a mistake, because I think it really is something fundamental that everyone should be using all the time. And so long as it's something that's only available to some users, people will hold back from using it and not take advantage of it. So I think we'd be delivering more value to users if we've actually included that in the baseline. It also means that because it's an optional feature, nothing else in the specs is allowed to depend on it. Everything that's dependent on higher order functions also has to be optional. And so you get this sort of cascading dependency problem that people were reluctant to define new features, new functionality in terms of higher order functions because higher order functions were optional. So that's one reason I think it's underused. Another is that I think the syntax is clumsy, and I'm going to suggest some improvements to the syntax to make them easier to use. And the third reason is that there's a limited repertoire of higher order functions in the standard library. I think if we had more good, useful features delivered via standard library higher order functions, people would get into the habit of using the ones in the standard library. And once they were in the habit of using higher order functions, they'd realize the potential of defining their own to add to that capability. So I think we'd break that sort of learning obstacle that says I've got no reason to use these things. So firstly, improving the syntax. Well, I would like to be able to write that instead of writing what's in red. And I think experience with languages like Java and JavaScript has shown that concise notations for higher order functions, lambda expressions or whatever you like to call them, have actually made a big difference to people's willingness to use them. What this syntax does is it says this is a function and I'm going to write it as an expression in terms of the context item. So it's a function that takes a single argument of type item, binds it to the context item, and then evaluates the expression with that as the context item. So if I want to sort employees by last name, then I just write this. And one of the bits of thinking behind that is, I don't think you use this syntax unless, if you look at this syntax, you think I need a PhD in computer science to understand that. You look it up in the spec and it talks about higher order functions and you think, no, that's not for me, it's too complicated. Most XSLT programmers don't know the computer science. They just see examples and they understand how they work. And if you see enough people writing sort expressions that look like dot with curly braces, then you just think of dot with curly braces as something you put in the third argument of a sort expression. And you don't really have to think, that's a function I've just written. A function is a value, I can pass a value to another function. You don't have to think in that mindset, you just think curly braces, that's what I do when I'm sorting. So an awful lot of the functions that we actually need in everyday life can actually fall into that pattern. For the slightly more complex ones that have multiple arguments or arguments that aren't single items, I think we can still come up with a simple notation, and this is the notation I propose. If you want a function that adds its arguments together, just write $1 plus $2. I think it's pretty visibly clear what that does. I think you can read that green expression. Well, perhaps you don't understand what fold left does. I always have to think 3 times before working out what fold left does. As far as the function is concerned, you can see that that's a function which adds its 2 arguments a lot quicker than you can see that that's a function that adds its 2 arguments. So I think simple syntax actually helps to make the things more usable. Now let's think about some examples of higher order functions I'd like to have in the library. Some of these are inspired by JavaScript, which I've had a bit more exposure to in the last year or 2. So how about a replace with function? What replace with does is it takes the first argument, which is a string, the second argument is a regular expression, and the third argument is a function which computes the replacement that you're going to replace the matched value with. So the result of this is that you match the string 13 in that string, you turn it into a number and you add 1 to it, and you end up with chapter 14. Wouldn't that be nice? Here's another one, map replace. I find all the time when I'm using maps, I'm putting a new value in the map that's a function of the old value in the map. So rather than getting the value, doing a computation, and then doing a put to put the new value in, let's have a map replace where I just supply the function that computes the new value from the old value. Simplify things a lot. This example just converts height and width to millimeters by applying a function, which in this case I haven't written in line, but I've put in a variable. It could equally well be an XSL function declaration, of course. It doesn't have to be a dynamic function. It could be a statically defined one. Here's another one that people are always asking for. How do I find everything up to the first H1 element? It is so ludicrously difficult to do that. When people ask that question, I think, what is the best recommendation to people to how to find everything up to the first H1 element? It is so hard to do. We need a function to do it, and it has to be a higher order function. So we have a predicate that says what you're matching, and then I've actually defined a family of 4 functions. Items before gives everything up to and excluding the first match, items 2 up to and including, and then things beyond and including, beyond and excluding. I think that would be a very useful family of functions to have in the spec, and they have to be higher order, and they'd get people used to using higher order functions and seeing the benefits of it. Highest and lowest have been Saxon extension functions for a very long time. And they're actually examples in the F&O spec, and I don't know why we didn't get them in as real functions in the library, because I'm having to use them all the time. You don't just want to know what the minimum and maximum salary are, which we've got in the standard function library. You want to know who has the highest salary, which book is the most expensive. You want the thing that has the maximum value for X. The XQuery examples of that are always tedious. You have to find the maximum, and then you have to do a search to find all the items whose value is equal to the maximum. And having to search the list twice is just so painful. The only other way of doing it is to sort them and then take the first item in the sorted sequence, which is equally painful. Let's have a nice syntax for doing it. Related to that, I think we need to be a bit more flexible about function arity. Again, experience with JavaScript leads me in this direction. Firstly, I think we should be able to declare a family of functions with XSL function. Now, there have been objections to that how do you ensure that functions are unique? Because they're distinguished by the arity of the function. The number of arguments is effectively parts of its name. Well, I think that's actually fairly easy. XSL function here, like this, with a default value for one of the parameters, is actually declaring 2 functions. So it's one function declaration. It's declaring 2 functions, a function of arity 2 and a function of arity 3. You can refer to those by #2 and #3 after the name. So you've got 2 different functions there, but they share a function declaration in common. So I don't think there's any conceptual difficulty in in mapping that to the model. It's just a convenient syntax for describing two functions that have the same name and different arity, that differ only in that one of them has a default value for one of the arguments. So I think that would be very handy to have and doesn't cause any real difficulty. I considered doing variadic functions as well, but I found that got a bit difficult. I still like to have another try at doing it, but it is a bit more difficult. And then then the other thing is function coercion says, what happens if you supply a function where the required type doesn't exactly match the function that you're supplying? And there's a set of rules that it applies. Basically, you've got quite a bit of freedom in supplying a function that doesn't exactly match. And basically, you end up getting runtime checking. So long as it handles the things that are actually passed to it at runtime, then it's fine, even if it's not declared to accept everything that might theoretically be handed to it. And that's a way of avoiding doing generics in the type signatures and things like that. But I think there's one extra little bit of freedom we could allow in function coercion, and that's allowing you to supply a function of lower arity than required. So in this example, the filter function requires a function of arity 1, so that's currently an error. You can't apply true/0 as an argument of the filter function, but it's completely clear what it means. It just means if you supply a function of arity 0, then it doesn't get to see the argument, and it has to make a decision without the value of that argument. So you just drop off arguments from the end down to the actual arity of the function that's supplied. One reason for that is that it actually allows you to extend the signatures of these functions so they can accept things with optional arguments. So if we decide to add an argument to deep equals that gives a set of options which are criteria for how you decide whether things are equal, then things can accept either the new form of deep equals or the old form with a default. They can be more flexible in accepting either, and therefore you get a bit more flexibility in extending the functions you've previously defined while remaining compatible with existing clients. So that's closely associated changes. So I've talked about types and patterns. I've talked about higher-order functions, and those were the two main themes I wanted to focus on. Also in my paper, I've put a list of goodies, because I find the simple little things that you put into a language often appeal to users far more immediately, because they can immediately take advantage of them. They can say, yes, I've always wanted that. So there's a few things in the paper that I hope tick the box on saying, yes, I've always wanted that. And I've selected one or two to actually put in the presentation. And some of them relate to conditionals. So I hope you can guess what that means. I hope you can see how you'd use it. There's currently a sort of workaround syntax that says discount or 0, square brackets, select the first applicable, which usually works but doesn't always, depending on whether the attribute can only select a single node or whether it can select multiple nodes. This basically says if discount exists, then use it, otherwise use 0. I find myself using that sort of construct all the time, so I'd like some handy syntax for it. Here's another one. How many times have people asked for that? The particular reason for that is that we're now very much more often manipulating things that aren't nodes. The current syntax for XSL if and for XSL when presumes that what you're probably doing is constructing nodes. So it's an XSLT 1.0 model of the world, that what style sheets do is create nodes in the result tree. But style sheets are doing much more than creating nodes in a result tree these days. And conditionals are very often returning atomic values, or returning maps, they're calling functions, they're doing XPathy sort of things rather than just XSLT sort of things. So being able to to put XPath expressions in the then and else branches of XSLT is just a no-brainer. And then, do you notice what you can't do in 3.0 there? Because I always imagine you can. The number of times I've tried to write that and then had the compiler tell me, no, you're not allowed to do that. XSL when is the only thing that doesn't have a select attribute. Everything else in the language, if you can write content, you can also write a select, but XSL when and XSL otherwise you can't. So that's, it is really stupid that we didn't fix that in 3.0. So that's just a few of the little goodies, and there's more ideas in the paper, and they are just ideas, except a lot of them, for example, nearly all those new functions I proposed, quite a few of them are implemented as extension functions already in existing releases of Sax, and the rest of them are nearly all implemented as extension functions in the next major release of Sax. And so, if they can't be in the standard function library, at least they can be extension functions. And some of these syntax things as well. The otherwise, for example, I can't remember whether that's in 9.9 or if it's only in 10.0, which will be coming out later this year. But if you set a switch that says extension syntax allowed, then you can use that syntax. At the moment, it's not allowed by default. By default, you still get 3.0 conformance. But there's experimental syntax for extensions in there. A few other goodies. Oh yes, this one we did for Sax and JS in the browser. Because the HTML5 spec unilaterally changed the XPath rules. They said, HTML5 supports XPath1 as defined in the W3C spec, except. And they changed the rules on namespace matching, which gives us an enormous problem. But what we decided to do was to make namespace matching a bit more flexible. We don't do it exactly as the HTML5 spec says because it doesn't work when you extend it to XSLT3 rather than to XSLT1. But you have the option now to say, when I write /A/B/C, it means match in any namespace. And nearly all the time, you don't care what namespace it's matching in. You've only got one thing called A and one thing called B and one thing called C. If you match that, you're fine. Why should I have to tell you what namespace it is when there's only one that matters? So an option to make unprefixed names match any namespace, I think is a big usability win. But, if you follow StackOverflow, there's one question a day from someone who says, my style sheet doesn't work, where the answer is, namespaces. It's just such a common trap. And the other one is, why on earth should you have to write XS:*integer? Why not just integer? The context is always unambiguous. You know it's a type. It's nearly always going to be an XS: type. Just write as equals integer. Why have to write all these colons? It just makes the code more obscure. Let's get rid of it. Modes. Biggest problem in debugging a complex style sheet is finding the template rules. They can be anywhere. They can be all over the place. You've got 20 modules. There's template rules for the same mode scattered all over those. How do you find which template rule caused this weird output that you've got? It's a nightmare. One way to solve that nightmare, I've always believed, is to enclose all the template rules for a particular mode inside the XSL mode element, and then you've only got one place to look. You still have to look for potential overrides, but by and large, you can scan all the rules visually. You can say, oh, it must be this one. You know you don't have to look at all 20 modules. You know they're all going to be in one module. I think that would simplify debugging. Another thing, when you write template rules that return maps, which you start doing, you find that all the template rules in a mode actually return the same kind of map. Because the apply templates instruction has to know what it's expecting. And so basically all the template rules that it might match have to return the same kind of thing. So why not write the as clause as part of the mode, so I know that template rule is always, I know that when I do an apply templates instruction, I know it's going to return a map of a particular type, rather than returning nodes or whatever. And another big advantage of that is that the compiler then knows what the XSL apply templates instruction is going to return, so it can do some type checking on the result that it's returned if you bind it to a variable. And type checking doesn't just give you a performance advantage. Far more importantly, it gives you much better diagnostics when you get things wrong. Instructions to process arrays, I won't dwell on those. And node constructor functions. Why can't we have functions that construct attribute and element nodes? The more you move into higher order functions, the more you want to provide functions that do anything. You want to provide all the functionality of the language in the form of functions that you can call, rather than in the form of custom syntax, which you have to wrap your own function around if you're going to pass it in places where functions are expected. So let's have some node constructor functions. Would often be handy. The other reason for that is XPath and XSLT orthogonality. Once you start writing things in XPath, having to break out to XSLT in order to do something becomes a pain. So you don't want to you want to minimize the number of times people have to break out artificially from XPath into XSLT coding. And providing that functionality reduces the number of times they have to do that. So that's a summary of what it is. So I'm open to questions, except the question, what you're going to do next, because I don't know. So I'll ask that question myself, what are you going to do next? I don't know. Are there any other questions?
I can certainly book room for next year to have a meeting here, but probably now we should go with questions. So, Matt over there.
Going back to definitions of basically inline function definitions for higher order functions. So in your, it's like the third argument for your whatever. In Ruby, which I've spent many years working with, we don't have higher order functions. We have lambdas and procs, which are functionally the same thing. And the thing I found with that is not having explicit variable definitions for the arguments being passed in can be quite confusing. And the things like the latest syntax for that in Ruby, the stabby lambda. That's what we call it.
I mean,
it's concise, but it gives you, and I just wonder if there are other models that might give you the conciseness you're looking for without. So I think there's actually, so with $1
I mean, I looked at a few things. The JavaScript arrow and the Java arrow both seem clunky and don't seem to work in this language too well. I looked at the way Scala does it, where all the arguments are referred to as underscore, and I just can't work out which underscore refers to which argument. So I've looked at a few other things, and yes, suggestions welcome. I've toyed with a few different syntaxes, and this is the one that appealed to me most, but it's an aesthetic judgment, whatever you, in this sort of area, whatever you choose, someone's going to throw tomatoes at you.
Well, first off, John Snelson was watching, apparently, because he was tweeting that you mentioned him. Very important. Second, I would love to see some open discussion where, I don't know, but with these proposals and others. I think basically every slide has a lot of beautiful ideas and also, of course, raises implementation questions, like how do we, well, make them unambiguous. And Last simple question is about the functions for creating nodes. What about elements? Recursive function, or?
No, I think you have a second argument which takes the content of the node, and that can create another element. So
that is a recursive function, basically.
Not recursive as such, but if you want to create a tree structure,
Yes.
then the second argument of new element would itself be another call on new element to create its children.
Got it. Thanks.
Hi. I've got a question about...
Sorry,
Here.
I don't know where to look. Okay, thanks.
About the tuples.
Yes.
You had one example with XX string was optional. So I was thinking about, is it only that it might be an empty sequence, or could it also be missing completely? Or is it just one of those?
I decided to, map-get currently doesn't distinguish absence from empty. And I decided it was simpler not to distinguish absent from empty. So you could go either way on that decision. I'm not 100% convinced I got it right. But I decided to err on the side of keeping it simple and not distinguish an empty value from an absent value.
A bit loud. Hi, Mike. I'm wondering, is this an appropriate time to make some suggestions for XSLT4 and discuss them, or is that opening the gates to madness? I have one in mind, obviously.
Why not let's have a discussion on the XSL list? It's been a bit quiet recently. Let's have a conversation there.
Okay, I shall do that. And if anyone's curious, they can ask me in the pub later.
Martin here, Fonto. If you look at this function over here, default let function, I like how all new types are being introduced and all new aliases for types especially are being introduced. In most functional languages, in most languages at all, you would see that one of these default left functions would be a generic function. It would have a type and parameterized types. So that the return of the callback function would also be the return of the full function. Would you consider those functions, those functionalities good for XQuery, XPath, XSLT?
Yeah, that sort of gets to generic types where, at the moment, we sort of leave implementers to the type inference. For example, you get that with ordinary simple functions. You know that subsequence is returning the same kind of items as its argument, but the function signature doesn't capture that. The function signature says the input contained any items, the output contained any items. There's nothing in the function signature that says the output items are going to be the same as the input. But typically the implementer knows that that's a property of the subsequence function. Now with user-defined functions, there's no way of declaring a similar property. That would get to generic types, and having seen what a nightmare generic types are in Java, I'm afraid my mental machinery says don't go there. But I'm sure people who understand type systems better would love to accept that challenge.
I would say please check out TypeScript, the implementation over there and how it's written, how it's used.
I'm sorry, I didn't...
TypeScript, the Microsoft JavaScript flavor-ish. It's basically JavaScript, but with types. And the type system over
TypeScript, there, yes. Yes, I guess that might be a model to look at, yeah.
Thanks.
Yeah. Type annotations of some kind.
Sorry, one more, Michael. About these higher order functions, to make them really powerful and useful, I think we need some kind of concept or way to pipe them, or to, what's the other word? Combine them. Like the pipe operator or the...
Yeah, actually, as I was doing these
arrow
slides,
operator.
I was thinking about that.
Because then you can really combine functions, give,
Yes.
pass functions on or extend functions by simply combining.
I was thinking the same thought, but I don't have an answer to the question.
Me neither, unfortunately.
That's very exciting. Thank you very much. I think it addressed a lot of usability points. I guess that's not really a question, that's more a suggestion. But your last point, suggesting that you should, that we should be able to use every XSLT construction from XPath itself. Even without that, but even more with that, I think it would be useful to have an element that the string content of which would be an XPath expression to be evaluated, because now we always have to rely on a select attribute, which sometimes feels a little bit...
I mean, the problem is we have a two-language system. We have XPath embedded in XSLT, and therefore there's an intrinsic lack of orthogonality that XSLT can invoke XPath, but XPath can't invoke XSLT. And that's a sort of, that's a feature of, a consequence of having two languages with different syntactic frameworks, one embedded in the other. I don't see any easy way around that.
Well, you know, something like XSL sequence.
I mean, obviously XSL function gave you a way of escaping from one language into the other, which was very much part of the thinking of adding XSL function, that it enables you to invoke XSLT things from XPath things, but providing a better way of doing it. I'm not sure I know how to do that.
Yeah, I guess I have something in mind more like if you had XSL current sequence type equal XPath or something, and then the string content of which is evaluated instead of using select.
Yeah, well,
like
write down your suggestions, I think.
XSL expression, yeah. Call it XQuery, I don't know.
Call it XQuery, yes.
Yeah, Mohamed Zagawi, I don't know if you know me. I have a question. Why do you insist on extending the XSLT language instead of just rewriting a new one, like, I don't know, DSSSL NG or something?
All the successful projects in my career have been built on improving something done by someone else. Whenever I've done a project that started something from scratch, it failed totally. So I guess it's my personal skill set.
Okay, any other questions? Probably no, but I think we will have a lot of things to discuss over the dinner and other places. So thank you again very much.
Thank you.